Keith.
Yo.
Hello. This is Bert here.
Hello. How do you do?
Good to meet you.
He needs to develop a CapTouch application and he has a lot of questions.
Yes.
Okay, certainly. Well, yeah. Thanks. Grab a chair.
Thank you.
Okay, so you're doing CapTouch.
Yes, my boss wants me to create an application with CapTouch buttons, but I don't really know what that is. So I was hoping you could help me out.
Okay. Well, actually, CapTouch is a very old technology. It's been around for a long time. Basically, it relies on the fact that your body is mostly water.
Okay.
Now, you remember in your EE101 class, any capacitor is basically just two conductors separated by an insulator. Okay. Well, the water in your body works very well as an insulator. It's got very high permittivity. So if we were to make a giant capacitor out of you, you'd make a very good capacitor, a lot of capacitance. What happens with CapTouch is we build a small sensor on the board,
Okay.
and when you touch it, you actually form a capacitor between that plate and ground,
Okay.
whether the ground's from you holding it or ground on the floor. Now, what happens when you do that, you actually cause an increase in the capacitance, and the microcontroller senses that, and that's what triggers the touch.
Okay, so then all I have to do is look for a shift in the value, and then I can make my detection?
Actually, it's a little more complicated than that. And there are actually two reasons for that. One, everything in the environment is going to affect the capacitance on that button. So one of the things we have to do in software is actually maintain a running average of what the capacitance is on that sensor. And then when you touch it, what we do is we look for a rapid change in the capacitance. So you do have to put some software behind it. The other thing you run into, the environment's not exactly a quiet one. There's going to be electrical noise. So we also have to put some filtering in the software to filter out the noise from lights and other things in the environment. So it's the combination of the two, the hardware and the software.
Okay, so I've got a shift in capacitance, but how do I actually measure that?
Okay, there's several options. One of the simplest methods is what's called CSM, or a capsense module. Basically, it builds an oscillator around that capacitance, and the frequency of the oscillator is determined by the capacitor. So when you touch it, it actually goes down in frequency.
Okay.
Now, a couple different ways we can measure that. We've got timers in most microcontrollers, so we can either measure the frequency, which is counting off 1,000 or so counts in a fixed period, and that gives us frequency, or we can count a smaller number of cycles and measure the period it takes for those cycles to be generated. Both will give us usable numbers.
Okay, what if I don't have a capsense module in my part though?
Well, actually, that's a nice thing about this kind of relaxation oscillator kind of system. You can do it with just a comparator. Make a simple oscillator, simple RC oscillator, put some hysteresis on the comparator, and most microcontrollers these days have comparators in them, so it's a pretty generic method. Now, you'll have to do some multiplexing externally. That's not usually a problem. Okay, another method we can use is a peripheral we call the charge time measurement unit, or the CTMU. What it does, if you remember basic capacitors, if you run a fixed current into a capacitor for a period of time, the voltage ramps up on the capacitor. It's a function of the capacitance value.
Okay.
Well, what we do with the CTMU is we run a regulated current in for a very fixed period of time, and then do an A to D conversion on the voltage across the capacitor. Then, as we scan through all the different channels, what we can do is look for a change in that level that indicates a touch by the user.
Okay.
Now, the final method is the CVD, or charge voltage division method. Here we take a known capacitance, such as the input capacitor on the ADC, we charge it to a fixed voltage, and then when it's put in parallel with the external unknown capacitor, what we get is a voltage reduction. How far that voltage moves tells us how big that external capacitor is. Now, for detecting a touch, and when a person touches that external pad, the unknown capacitance goes up. As a result, our voltage that we measure goes down. The nice thing about this is that it uses an ADC, so any micro can be used. It's got an ADC on board.
So we've got several different ways of making this capacitive measurement. How do we actually choose which one to use?
Well, actually, the method to use is not really chosen from the capsense side. What you need to do is find out which microcontroller is going to have the peripherals and functions you need for the rest of your circuit, and then you just choose the appropriate method. We'll move to work with whichever peripherals you have on that particular part. If you have a part that's got a CSM, you can use a CSM system. If you've got one that's got an A to D, you can do the CVD. It all depends on what other things you need to do. That's a nice thing about having several different methods for doing cap conversion.
Okay, great. Well, now that I have all this information, how do I get started?
Okay, well, a couple different things we can do. We have several demonstration boards that are available that basically will allow you to play with it and try the code out and all the different methods. We have a demo board. We also have our development board. Now, the development board is nice because the electronics and the touch sensors are on two separate boards. So what you can do is make up your own front panel with up to 16 buttons on it. Plug this board into it, and all the electronics are done for you in advance. Now, you plug that into your computer, modify the software from the libraries that we supply, and boom, you've got a system up and running. You don't have to fight all the way through the code development. You can take a lot of what we've done and modify it. And that's the other nice thing. We supply the source files for this information, or for the libraries as well. So if you find you want to modify something, you want to change how certain buttons work, maybe some buttons are harder to press than others, however you want to do it, with the source code you can modify it and customize it for your particular design. The whole philosophy has been, when you get done, the code is yours. It's not something we supplied you, it's something that belongs to you and it's part of your product.
All right, well, Keith, thank you very much. I appreciate it.
You're welcome. Good luck with your project.
All right, have a good day.
Thank you.